Alright, so in this video, we're going to talk about how to visualize the error in the classifier. Okay, and the best way to do this is with a matrix, and the idea behind the matrix is that along the vertical here, we're going to have predicted values, predicted class, and on the other axis we'll have the actual class. And so suppose that we have, I think in the example in your notes we have three classes. And so we have, what was it? Oh, well, I'll just call it 1, 2, and 3. Although it's cats, or dogs, cats, and rabbits. And then over here we have class 1, class 2, class 3. Okay, and then we had some numbers, 23, 12, oops, 7, 11, 29, 13, and 4, 10, 14, 4, 10, 24. Okay, and so how should we read this? This is, by the way, is called a confusion matrix. And so the idea here is that we can take a look and see exactly how things were classified, and more importantly how things were misclassified. So if we look at the diagonal elements, by the way, the numbers that you see in the cells are the number of times this happened. And so there was 23 total instances where we had predicted class 1 and the actual class was class 1. Or another way to say that is we classified the picture as a dog when the actual thing was a dog. Okay, and so it's these diagonal values that are the accuracy, right? And so the off-diagonal elements are telling you how the error is being done. So in this case, this is a pretty high value here, this 12. This means that if I were to think about all the ways I've classified a dog, 12 times, or I predicted a dog, 12 times I was wrong and and the actual thing was a cat. Okay, and so if you go across like this, you can say, well, let's see, what are those numbers? 23 plus 12 plus 7, so that's 42 instances altogether. And so 12 out of 42 of those times it was classified as a cat, and so that's 29%. Wowee, 29%. So 29% of my predictions were wrong, right? So predictions of the dog. That's a pretty high error rate for that. So dogs are getting misclassified as cats. Similarly down here, right, this is rabbits, and this is saying when we're predicting a rabbit, 10 times it was actually a cat. Cats look like rabbits and dogs, apparently. So what's that error rate? That was 10 divided by the sum across, right? So that would be 28, 38. Okay, so 10 divided by 38 is our probability, so that's about 26%. Okay, and now to get the overall accuracy, we would sum our diagonal elements divided by the sum of all of the cells. Okay, because remember, the sum of all of the cells is the number of times our number of trials or number of data points. So if I sum them all, what do I get? I think I wrote it down here somewhere. 133 total. You can double check that. 133. And so what was the sum of our diagonal elements? 74. Sum of diagonal 74. So therefore the overall accuracy would be 74 over 133, and that is 50%, 57% accuracy. Good. All right, so that's not too bad. And like I said, the nice thing about using the confusion matrix is you can really tell if there are errors. Why are there errors? You know, I've been in situations where everything was perfect except we had something like, you know, if you have you might have 0 there, so we might have 0 in all of these, and then all of the error, when there was some, was all in this one box. You know, it was like 33 or something, and then everything else was blank. Oh, I guess maybe this is a little bit symmetric, so you might have like 15 over here. And so, do you see what this would represent in terms of a classification problem? So what's happening is that class 3 is like perfectly separated from classes 1 and 2. Classes 1 and 2 are getting mixed together, and so you can really see what's happening in your data when you're using a confusion matrix. Good. So this is a way we can analyze the output of our classifier. Alright, so I'm going to stop here, and in the next video for the next day, I think I'm going to stop here for the day, and because I don't want to get too far ahead of you. And so the homework tonight is going to be to start the code for K nearest neighbor classifier, and also take a look at page 124. There's only one homework problem in the book so far, and that's because I'm going to put the coding problems in a different spot. But take a look at number 1. It has to do with something called the Curse of Dimensionality. You might have heard that phrase. I don't know if I've used that phrase before, but the Curse of Dimensionality has to do with the complexity of the problem as the number of dimensions goes up. In this case, what we're going to see is that K nearest neighbors tend not to work well in high dimensional space, and the question is kind of leading you to that conclusion. Good. So try out that little piece of code there in the homework, and we'll do a little bit of coding for the K nearest neighbors, and we'll see how it goes. Okay, I'll talk to you later.